Hey everyone, welcome again to IT Horror Stories with Jack Smith. I am Jack Smith, and across the table today I have Mooly Beeri. Sir, good evening. How are you doing?
Yeah, good evening. Thanks for hosting me.
I'm more than happy to have you. Mooly, for the people that do not know you in a nutshell, how would you describe yourself to get going?
Well, I'm a software guy with almost 30 years of experience from multiple startups and from Microsoft and Philips. I had the luck and I was fortunate to build the first software center of excellence for Philips. And then I enjoyed the space of software excellence. I created my own company around it called Better Software, and I'm doing large scale software transformations with large automotive clients for automotive and healthcare clients for many years. So that's
Okay.
who I am. Yeah.
Mhm. Okay, so Mooly, so you mentioned the automotive sector, and knowing that cars are slowly transforming into driving data centers,
Yeah.
there has to be something going on there. So, how about we talk about the automotive sector?
Yeah. Good. Good. Yeah, the automotive sector is becoming more and more dependent on software with software-defined vehicles and more powerful microcontrollers and computers in the cars and updates over the air and so on. And the software becomes very complex, and it's also provided by many different players in the space. So if you look at a single car, the software running in that car comes from a large variety of suppliers. One
Hmm.
supplier is delivering the software that controls the braking, another one the steering, another one the infotainment system, another one the dashboard and steering and autonomous driving and so on. And it becomes a really big challenge integrating all of this software and coming up with a piece of software that is reliable and can safely run a car or millions of cars
Hmm.
without bugs. Yeah.
If you then put it all together, this magically has to integrate and cooperate. I there have to be challenges there.
Yeah, for sure. These integration projects are usually very long and require multiple participants to play along. And it usually involves hundreds, if not thousands, of bugs that have to be resolved on even on a monthly basis.
Mhm.
And the way this is being resolved today for most OEMs is taking huge buffers in terms of years for developing, stabilizing, and getting all the bugs beaten out of the system very slowly. So it's not uncommon for automotive players to work now on software releases that are scheduled to be released in 3 to 5 years, which is very counterintuitive when you think about the rapid pace of software releases today. When you get a new AI model twice a week or new updates delivered to your phone twice a day. So the challenge is quite significant. It's actually one of the reasons we're talking today, because I've personally worked in multiple projects where the teams had to cope with, even at some extreme cases, 2 or 3 thousand defects every month. Imagine that, working on a project
Oh,
where you
yeah.
have to process and fix, or even not fix, but make a decision about 2,000 defects or bugs every month.
I would imagine that's a lot of assumptions that, oh, it will be okay, it will be fixed, and then in the end, I'm just imagining all the tests that you have to throw against it to make sure that all your regression is there, and
Yeah, so
it's humongous.
maybe I can choose one specific example.
Sure, go ahead.
Um, so a really large automotive player, let's say one of the most famous cars in the world, working on a project where there are approximately 2,000 bugs
Mm-hmm.
every month. Of course, there's the bugs are just a side effect. The main thing is that features are getting delivered on a daily and weekly basis. But as features get delivered, also bugs get generated. And if you think about the world of electronics, there is this concept of signal to noise
Mm-hmm.
that we know well, or basically the value versus the overhead. And you always want to work in an engineering environment where the overhead or the noise is under control and it's small and you provide a lot of value. And okay, you maybe sometimes while you provide value, there is some side effect that needs to be handled, but that side effect needs to be managed. And whatever it is, you're hoping to get it smaller and smaller over time. So whatever the side effect is, you want to get your processes improved such that the waste in your engineering process gets smaller over time. So if I go back to that example of the team that I mentioned, they were working in an environment where about 60% of their time was spent on processing bugs.
Mm-hmm.
So essentially, a large team, probably close to 1,000 engineers, and about 600 of them are working full time just on fixing bugs. They don't deliver any value to the project except for fixing the mess that's created by the other 400 engineers. And so you can imagine that this project is quite wasteful.
Mm-hmm.
And the the problem is that most of the teams working in large enterprises today, they work under a specific process, and it's divided into iterations, whether they're using Agile or Safe or Scrum or whatever. But they usually invest quite little in improving their processes. So they go through iteration over iteration using the exact same process. And if the process is such that it generates 60% noise and only 40% value, and you repeat the same process again and again, you will again and again generate 60% noise. And that's exactly what those teams were facing. So basically, every iteration, they were getting a little bit closer to the target because they delivered more features, but they were also drowning more and more in technical debt. They were
Mm-hmm.
creating thousands of defects every month. And
Yes.
the software systems today are so complex that when you implement whatever change you implement, you always create some regression in the system. So the in many years ago, the systems were a bit more simple, and you could theoretically keep the system in your head, and so making one change and somehow controlling what impact is done to the system and being able to predict where things would go wrong. But in today's systems, they are so complex that there's no way you can keep the different scenarios and complexities in your
Mm-hmm.
mind. And
Yep.
so when you make a change, it's not a question of did you create some regression in some other functionality. It's usually almost guaranteed that there is a regression. And the only way to catch that is by having a solid test automation framework that can run continuously and give you these alerts saying, okay, you implemented this functionality or a certain functionality, but you accidentally also created this type of problem which has to be fixed. And so there is actually research that shows that the probability of creating a regression in a complex product when touching a single line of code is greater than 60%. So it's almost probable when you make significant changes that some regressions happen. So going back to that example, the team I was trying to help, they were fighting with about 2,000 defects per month.
Mm-hmm.
And when we started, and of course, some of them, most of them are discovered internally, but quite a significant portion of those are discovered by customers. And every time a defect is found by a customer, that includes customer escalation calls, reputation costs, and working over weekends, and so on and so forth. And so we started looking at this pool of 2,000 defects and trying to analyze what are the root causes, where are they coming from, and and basically map these defects into their process areas. Are those coming from problems caused by static analysis? Are those problems that are isolated to specific components and could be found using unit test? Are those integration problems that could be found by testing the relations between the different components, or coming from the need to integrate third-party products or third-party code?
Don't miss an episode. Subscribe now on Spotify, Apple Podcasts, YouTube, and more. Support us by leaving a like or a review. You can always find more at ithorrorstories.eu, and we're just an email away at hello@ithorrorstories.eu.
For each of these process areas, we defined the specific test cases, test suites, and started running those continuously as part of their CI/CD, continuous integration environment. And basically, when these failed, we blocked the ability to integrate. In essence, what we started to implement was some hard gating of failures. And the team was mostly in the mindset of, we are going to deliver first and fix later. So we'll first deliver the new content, and later, when or if we find a regression, we're going to fix it if it becomes a priority.
Okay.
And
Yeah.
and the mindset shift was, if you need to fix something, the cheapest option is to fix it as early as possible.
Mm-hmm.
So if you know a failure is there, there's no point in postponing the decision to fix. You have to fix it immediately. And so what we started doing is, with every 2-week iteration, is to plug into their process a small process enhancement. For instance, I'll just give you a very simple example.
Sure.
The team was very determined on fixing all the static analysis violations. But the way they did it was first integrate all the changes, then once in a couple of weeks run the static analysis scan, and whatever is a critical finding, they would file bugs, which would add up to the 2,000 bugs
Yes.
in a month. And these bugs would get triaged and processed and assigned and so on. So the first thing that happens is that when these problems are introduced into the code, if there are serious problems, they're not stopped. They're getting into the code first.
Mm-hmm.
Second thing that happens, these require effort for triaging. Someone needs to look at every one of these issues and decide whether it's worth fixing or not.
Indeed.
And third thing that happens is this gets assigned not to the same person who created the code. And so you also miss the opportunity of helping the developer create
And then they
higher
have to
quality code.
relearn what
Yeah.
they did. And if I can jump in, because you mentioned some nice topics that I wanted to quickly jump onto, because you said for the triage and for the priority, who decides how much can be fixed? An example from my career and a few customers is that you get full blown into crunch time and you have a hard deadline in 1 week, and you find out that you have 15, 20, 25 showstoppers. And I've noticed multiple times that, say, the delivery manager and some project managers, they go into a room and magically you go from 25 showstoppers to 5 showstoppers that they then focus on. And then those 20, they magically disappear. Those will, without a doubt, somewhere pop up. Is this something that still happens or that you have seen happening?
Yeah,
How does
yeah,
that go?
yeah, for sure. If you find, let's say, 1,000 bugs in your test cycle, internal
Mm-hmm.
test cycle, it's almost certain that about 10% of those will be found by your customer. So
Mm-hmm.
if you found 1,000, you know there are 100 customer escalations waiting
That will
for.
show up. Mm-hmm.
Now, in some industries, they prefer speed. So I spoke earlier about different versions of AI engines. They don't
Yes.
really care if they make mistakes,
No.
because if you ask ChatGPT what's the date and it says the wrong date, and you say, hey, it's the wrong date, they say, oh, you're right, I got
Of
the wrong
course.
date.
Yeah.
That's not going to be
Good
a
catch.
customer escalation. Yeah. But if you look at your gas meter in the car and it
Mm-hmm.
says it's full, and then you get stuck because the gas is actually empty, it will be a customer escalation. Or I just had another client of mine. They had customer escalations with the wrong notification. The notification said they have to change their steering system,
Yes.
where actually the problem was low battery in the car. So with each industry has a different sensitivity to customer escalations. But going back to your question, if you know how many bugs you found in your internal test cycle, it's
Mm-hmm.
almost mathematically proven that about 10% of those will become customer escalations.
Mm-hmm.
And whether you are willing to sustain that or not really depends on your condition in life, your customers' willingness to accept unstable software. But in automotive, this is really a big problem. And and that's exactly the reason that accumulating this technical debt is becoming a bigger and bigger problem. And then you see projects that require 2 years to stabilize before they are
Yes.
willing to actually deliver something to the market, because they can't sustain a customer escalation.
I speak from experience with my vehicle that had exactly that, where the entire software stack had to be rewritten, and that took a few years before the update. And then you mentioned the over-the-air updates.
Yeah.
It took them 4 years in the life cycle of my vehicle to get it fixed. Actually, I had to go to the dealer multiple times for a module that needed an update before the entire over the air was indeed done. So the entire discovery to fix to implementation time is, as you mentioned, humongous. It's very, very long.
Yeah, exactly. And and of course the teams are under pressure to deliver, and it's
Mm-hmm.
kind of a vicious cycle, because project management and delivery, they know that they're going to get poor software. They require longer and longer stabilization periods.
Mm-hmm.
Um, and so they put more and more pressure on the software teams to deliver faster so that they can go through a longer stabilization period. And so they deliver less and less stable software, which takes longer and longer to stabilize. And in most of the cases, they're doing the stabilization at the end, which is usually the least cost effective way of
Mm-hmm.
doing the stabilization. So in the example I gave, one of the very small changes we made was that every static analysis finding, if it had to be fixed, it was flagged to the developer at the point where it was generated and
Yes.
fixed
Okay.
at the injection point. And
Mm-hmm.
so just by doing that, we achieve a couple of goals. The developers produce better and better code over time, And a big chunk of bugs don't even get filed because when you run the static analysis scan, it's clean.
Mm-hmm.
And so you go through the software development lifecycle step by step and find out how many problems arise from wrong unit testing, wrong integration testing, wrong qualification, and so on. And you go and optimize each of those and basically force the teams to do everything upstream and look at the injection points and try to the cost of a bug is exponential to the time that it spends in the system. So for
Mm-hmm.
every bug there is the injection point and there is the detection point.
Yeah.
Okay, is the
Is
time it
it
was created
uh,
and the
is it
time it was.
safe? Sorry to jump in. Is it safe to say that because if you have a bug and you leave it in because you do your bug fixing at the end, that all the other features that this bug will break also become bugs which you then also have to register and handle, and these don't come in, and that's where I would see a tremendous gain in resources and just technical debt that is not even created. Am I
Yeah,
getting this right?
yeah. I think you're absolutely right. The reason the cost of a bug is exponential is because when the bug gets introduced and enters the system, it starts impacting multiple developers in the group.
Mm-hmm.
And the same bug is basically investigated by multiple people and
Mm-hmm.
perhaps even filed multiple times. And then someone
Indeed.
needs to realize it's the same bug and start
Mm-hmm.
closing it. And so if you look at injection point, the time the bug was created,
Yes.
and detection point, when was it found, you're trying to minimize that gap as much as possible.
Mm-hmm.
Now, the bugs can only be created in three places: in requirements, in design, and in implementation.
Mm-hmm.
These are the only places where bugs get created. And so, usually, in many teams, the detection only happens when they are preparing for a release. Okay, and
Okay.
so
Yeah.
the
Yeah. Yeah.
bugs they live in the system for a long, long time, and you have to move the detection points as early as possible
Mm-hmm.
and start measuring the problems way before they get integrated, way before your mainline gets contaminated by these bugs.
Okay. You have your methodology. Which one then leads better to apply this system? Is it more waterfall? Is it more agile? Or can both be adapted? Because I can imagine that if you're agile before you do an entire test, it can take quite a while. With waterfall, you have more fixed point in times. Although you can do it with epics and agile as well, of course. But is there a difference between those?
There is no significant or conceptual difference
Mm-hmm.
between those methodologies. The injection points are the same, and
Okay.
the detection points are known for each one. And then whatever process you're following, it's really about trying to minimize or get the detection point to become as close as possible to the injection point. So, in the framework that we apply, we talk about fixing problems at the injection point.
This podcast features Jack Smith and guests. We say thank you to our demo scene friends who helped making this podcast possible. Commander Homer for editing, Danko for music and audio advice, NetPoet for additional voiceovers.
And so we're trying to fix it at injection. And so it doesn't really matter which methodology you use, as
Okay.
long
Yeah.
as you can find the problems very close to the injection point. And with that specific example, after working with that team for about a year, we
Mm-hmm.
had some quite nice results. We were able to reduce the number of overall bugs in the system by a little bit more than 40%. So that
Significant.
team was actually performing at very close to 1,000 defects per month, which is still quite high, but almost half of what they were doing before. And you can imagine that translates to quite a big capacity that is suddenly free. People that can actually
Absolutely.
deliver features, or the same team that can deliver the same content with less people. And so we usually see 20 to 30% reductions in a year, depending on how successful we are. In the best case ever, we had some luck and we're able to fix a specific system and reduce the number of bugs by 90%.
Wow.
But that was really a special case. But actually, it was a team that owned a critical component in a car. Every time this component had a bug, the car would stop because it was well, don't want to go into the specifics, but it was a component that would basically the car had to be towed every time they had an issue, and they
Okay.
had quite a lot of customer issues, and they didn't really know how to resolve them. We did our analysis. Again, the same thing, the injection point, detection point, how do you find all the problems earlier? And in this case, the team had all the right building blocks. They were not using them in the right order. And by sorting out their process a little bit, we were able to get 90% reduction in the defects. It doesn't mean that developers became significantly better. It's just that most of the problems are now found so much earlier that they're fixed before they're even submitted into the mainline. And so that made a huge difference for that team
I
in
can
terms of,
imagine.
yeah.
Yes. So, and then with your methodology, because our listeners are mostly the admins and the architects and the security people, if there would be a message from you, from the development side to them to say, hey, we hear you, we are working together with you, would you have a message for them to say it's going to be okay? Is there some is there something up your sleeve? Because the average audience thinks that developers are annoying, which I know they're not.
Well, the working with many development teams over the years, it's interesting that developers think the problem is with the product guys that are defining the product, and requirements are the problem. The guys who are writing the requirements think developers are the problem. The testers think developers are the problems. The developers think the testers are the problem. But the I would say the real challenge is that the teams are working in their own silos and trying to optimize
Correct.
their own silos. And very few people look at the entire system and try to optimize it. And if you go back to the learnings of Deming and early industrialization, the the impact on the overall result is usually the way the system is designed. And so if you design the system in a way that the developers and testers don't speak, they speak through releases, then you will always find the bugs too late. And if you design the system in a way that every time a feature is written, the test person has to be there and sign off on the implementation, you will have very few bugs. So the from my experience, there is no single discipline who is to blame, but many teams are not optimizing the system so that it works for their benefit. They repeat the same process, and therefore they get the same results.
You Last thing I want to jump on, because you mentioned it and it's actually important. You mentioned, the architects, the designers, the developers, the testers. What's in the framework that you described? What's a good communication method? Is it stand-ups? Is it weekly meetings? Is it a bunch of emails? Because people have to communicate and then say, "Hey, I found a bug in a test scenario. It's fixed. Can you retest?" How does communication ideally work between those teams?
Yeah, I think the best communication, I don't have a specific method of communication, but the
Okay.
best communication is really understanding that you're working in a complex environment with multiple stakeholders, and every time you discuss a specific work item, make sure you have other disciplines involved in the same. When you implement, I'll give you a very simple example. When you
Sure.
implement a new story, a new feature, you
Yes.
as the developer, you know already, if you think about it, that when you develop this feature, some existing test, is going to fail
Yes.
because you're changing the behavior. And so when you do that, reach out to your test counterpart and let them know this is coming.
Mm-hmm.
And when you're a product manager and you're writing a feature, you know it needs to be tested. So get your test counterpart to look at this feature and tell
Mm-hmm.
you whether it's testable or not. So the method of communication is not so important, but realizing you're working in a complex environment is the important thing, and understanding there is a system, and understanding there is the problems are too big for a single person to solve. So you have to communicate with your peers. You have to understand what you're doing has
Mm-hmm.
impact on other teams and communicate that impact to the other teams. There are many methods, but the most important thing, I think, is the awareness.
Mm-hmm. And if you, from all the discussion, there is 3 points to get into the technical debt removal and prevention. If we tell our listeners 3 points to think about, 3 points to take with you, 3 points to remember, what would those be for you, sir?
Yeah. So I think the first one is try to look at the stream of incoming bugs and understand why they're coming. We usually look at the stream of bugs and try to understand what the bugs are to fix them, but we
Mm-hmm.
rarely look at the root causes of why they are coming. Why were they caused? Why were they not found by the developers when the code was created? So first thing is understand what the root causes of you think about the incoming bugs as a opportunity for improvement, each one of those,
Mm-hmm.
and and get into the habit of learning from those bugs. So first thing is really you get enough feedback every day about what's wrong, looking at the stream of bugs. That's the
Yep.
first thing. Second is experiment with your process. If you're working with a certain process and it's generating a certain amount of bugs, you have to change your process from iteration to iteration. And it doesn't really matter how you change it, just experiment with it.
Mm-hmm.
You're trying something out, you know bugs are coming, try something different in the next iteration. Have two more people do the code review, have some tests run earlier, have
Mm-hmm.
a different checklist, have a different merge gate in your CI/CD. It doesn't matter. Experiment with your process, and try to find a good balance for your company. And maybe the third is really try to look at the whole system. Try to optimize the system
Mm-hmm.
so that you understand what is the weakest point in your entire software development lifecycle. I see a lot of improvements that are focused on the wrong thing. imagine a team buying a very expensive license for Claude Code with many tokens and whatever, improving the pace at which they generate code. But if you look at the entire system, their problem is requirement stability. So they are developing faster and faster the wrong requirements. And so getting more tokens for the Claude Code will cost them 100K every month, but will get them nowhere closer into getting the right product in front
Very,
of the
very,
customer.
very true. Absolutely. Yeah.
So understand what is the weakest point in your software development lifecycle and focus all of your energy on optimizing that.
Sounds fascinating. If people want to hear more from you, Mooly, because we only have touched the surface of your
Yeah.
knowledge and what you can do, if people say, I want to hear more about Mooly, where can they find you? Because I think you have gathered some interest here.
Well, you can go to our company's website. This is bettersoftware.dev. So that's one place. And also you can look me up or the company on LinkedIn. So Mooly Beeri on LinkedIn. I'm usually quite responsive there. If you leave me a message, I'll get back to you quite quickly, or the company's webpage on LinkedIn. So all of these are good ways of getting in touch.
Mooly, thank you for your insight. I think this was, for our listeners, a very different but extremely insightful episode, looking from the other side of the fence, because developers is usually not something that we have in our portfolio. And I'm really happy that I could have your views, opinions, and knowledge on it. So thank you very much for that. I really appreciate it. Oh, go ahead.
No, I just wanted to thank you for hosting me. It's always fun, and these are topics I'm passionate about. So I always enjoy when I have an opportunity to have a good discussion around those topics.
Thank you, Mooly, for joining us. This was IT Horror Stories with Jack Smith. As always, you can find us on Spotify, Apple Music, YouTube, Deezer, and wherever you find your panic attacks. We have multiple episodes a month. Our website, ithorrorstories.eu, merchandising shop.ithorrorstories.eu, and our socials on Instagram, TikTok, Facebook, LinkedIn, Blue Sky, and Mastodon. Yes, the more professional IT-minded networks are there as well. You can find those on links.ithorrorstories.eu. Thank you for tuning in, and we will hear each other in the next one.
The content of this podcast is intended for entertainment purposes only and is meant to humorously explore various tech-related situations. Any resemblance to actual events or real persons, living or dead, is purely coincidental. We ridicule situations, never individuals or groups. Listener discretion is advised, and we encourage everyone to approach technology with a sense of humor and an open mind.